All right, friends, welcome back. In this video, I'd like to go ahead and take a part one for day 2 of section 1.6 of your textbook. And again, remember that 1.6 just focuses on how to solve various types of equations. And so instead of having one video that covers everything, I'm having a couple of different videos that cover the multiple different types of equations that you're going to solve. And so in this video specifically, we're going to take a look at your absolute value equations. Okay, and so again, this is not the first time that we've seen absolute value equations, but we are going to kind of discuss them here again in this video, and here are some steps for doing that. One of the things that I am never really a big fan of is putting math into a context where you just apply a bunch of random steps that don't seem like they're coming from anywhere, right? So if that's the way that you like to study math, then here are the steps here. You can feel free to rock and roll with these, but I'm going to go ahead and explain how you're going to solve your absolute value equations by going back to the definition of absolute value, and that is a number's distance away from 0 on the number line. So the way that I'm going to go ahead and make some sense out of these equations here is I'm going to draw myself a number line. I'm going to go back to what absolute value actually means and let that be the thing that kind of helps me remember how to set my equations up. So let's go ahead and get started with that here. In this first example, we have the absolute value of x plus 3 is equal to 7. Okay, and so the way I would like to go ahead and explain this is by explaining that, whatever's in between the bars, that is the number that you're trying to figure out how far that is away from 0. Okay, so if we go ahead and draw a number line here, okay, we're interested in how far away from 0 we are. And again, we're taking the absolute value of some number, and it equals 7, quote-unquote, steps away from 0, is what we're saying, okay? Well, if you think about the numbers that are 7 steps away from 0 on the number line, if you were to go 7 steps to the right, then you would be landing at positive 7. If you were to go 7 steps to the left, you would be landing at negative 7. So that means that the number that is in between the bars here is either going to be positive 7 itself, or it's going to be negative 7. Okay, so that would be what we would have. But the number in between the bars here was not question mark or 7 or negative 7. What we were originally given was x plus 3. Okay, and so the way that we're going to interpret this is that whatever number this is, x plus 3, we know that that number has to be equal to one of two things because these are the only two numbers that are 7 steps away from 0. Okay, so x plus 3 is either equal to negative 7 or x plus 3 is equal to positive 7. And so that is the reason behind why we would set up our equation and split it up in this way. And this is how I'm going to go ahead and explain every single one of these today. And now that you have these set up, you're just going to go ahead and perform your inverse operations and get that x by itself. So I'm just going to simply subtract 3 from both sides of these equations here. You end up here with x is equal to negative 10 as your first result, and x is equal to positive 4 as your second result, okay? And so these are going to be some results that I'm going to go ahead and box here. And it does say up here, check your answers unless your absolute value equals number. Again, we're going to kind of make some sense out of what that means here in a little bit later on, okay? Now, the reason that we were able to do that one so quickly is because we already started off with the absolute value bars equals a certain number of steps, okay? If you were given one like number 2 where that is not necessarily ready to go for you, we would just need to go ahead and perform a step to get that absolute value expression completely by itself. And so for that reason on number 2, the first thing I'm going to do is go ahead and get that plus 4 over to the other side. So here we would have the absolute value expression. The absolute value of 2x plus 1 is equal to 3 plus 4, which makes 7. And of course, we go ahead and copy over the exact same interpretation as from before, right? So if I have this number line here and I'm at 0, again, I want to be 7 quote-unquote steps away from 0. Whatever this number, 2x plus 1 is, I know that when I take the absolute value of it, it's going to give me 7 steps away from 0. So if I go 7 steps to the right, I am at 7. If I go 7 steps to the left, I am at negative 7. So that means that this mystery number, this 2x plus 1 is either equal to negative 7 or 2x plus 1 is equal to positive 7 because those are the only numbers that are 7 steps away from 0. And so that's why I would split it up in the way that I do. 2x plus 1 is equal to negative 7. 2x plus 1 is equal to positive 7. And then I would just go ahead and solve these both individually, just doing your inverse operations, nothing special here at this point. We're just going to go ahead and subtract 1 from both sides, in which case we're going to get 2x is equal to negative 8 on that equation on the left, and 2x is equal to 6 on that equation on the right. And then, of course, we would just simply go ahead and divide both sides by 2 in both of these equations, and we would get 2 different results. We would end up here with x is equal to negative 4 as our first result, and x is equal to positive 3 as our second result. Okay, so very, very easily checkable in the calculator. Same thing on number 3. We just want to go ahead and make sure that we subtract the 3 over to the other side to make sure that we get that absolute value expression by itself. So 2x minus 5, the absolute value, is going to be equal to negative 3. And again, this is another reason why I prefer to go ahead and dip this into the context of the number line and actually draw one, because if you have an equation like this, then you might recognize that this is a little bit weird. We're saying that the absolute value of this number, 2x minus 5, the distance away from 0, is going to be negative 3 steps. Well, that kind of presents a problem for us, because we can't be negative 3 steps away from 0 because we don't count steps with negative numbers. How would we even interpret that, right? If we have a number line here and here is 0, and then we say go negative 3 steps to the right and go negative 3 steps to the left, it'd be kind of one of those things where it's like, well, how do I do that? Because I don't really count using negative steps here. And so what is our conclusion going to be? Well, folks, you can think about this anytime you have the absolute value bars equal a negative number, because we would interpret that in that way. We can't be a negative number of steps away from 0. So our conclusion here is going to be, folks, that we don't have any solution, okay? So no solution to this equation exists. So be on the lookout for absolute value bars equals a negative number, because we can't be a negative number of steps away from 0. And then we have some equations like this. So again, we have some x's showing up outside of the absolute value, but we don't interpret it any differently. We would still interpret this as there's some number out there, x, that if we were to find its distance away from 0, then it would be this number of steps away. It would be a number that's equal to x squared plus x minus 3 steps away from 0, okay? And so if we were to go x squared plus x minus 3 steps to the right from 0, then we would land here in positive territory, and that would be just x squared plus x minus 3. Whatever that number is, that's where we would have landed. If we were to go to the left in that same number of steps, then we might land in negative territory, and where would we be? Well, we would be at whatever the negative version of this number was, okay? So we would be at whatever the negative version of x squared plus x minus 3 is. Okay, and so that is why, since we are trying to find the absolute value of x, we know that it can only be one of two candidates. We know that x is either equal to the positive candidate or x is equal to the negative candidate. Okay, and so that is the reason why we would split it up and set it up in these ways. So we would say here negative x squared plus x minus 3 is equal to x, or separately, we could say positive x squared plus x minus 3 is equal to x, okay? In which case, we would just need to go ahead and clean these up, get that equals 0, because we have a couple of quadratic equations here, right? So I might go ahead and distribute that negative 1 in, and then bring the x over on the left-hand side here. So that is going to be negative x minus x plus 3 is equal to x, and then go ahead and subtract your x from the right over to the left. So we'd have here negative x squared minus 2x plus 3 is equal to 0. And then we might be able to go ahead and continue to solve that quadratic equation. You could do a slew of different methods. I'm going to go ahead and stick with some factoring here. So I'm going to factor out a GCF of negative 1. And see here, let's see, is that going to factor very nicely for me if I were to do it this way? I believe I could do a combination. Yeah, that could factor for me really nicely. I was overthinking that. You could factor that into x, and then my two numbers here, of course, are going to be some combination of 1 and 3. I believe a positive 3 and a negative 1 would do just fine, in which case we end up with the following results here. We get x is equal to positive 1 and x is equal to negative 3 as our two solutions from that side of the equation. If we were to take care of the other one here, we would subtract x from both sides, and then we would see here that we end up with the quadratic equation x squared, and then your x's just disappear, so minus 3 is equal to 0, in which case if you bring that 3 over, we can go ahead and use our inverse operations over here because that x fell out of the problem, and we only have x in one term, and that's in our x squared term. That would be x squared is equal to 3, in which case we would take a plus or minus square root of both sides here and see that x could be equal to the positive or negative square root of x, okay? Now, very, very important, and this is a special note you will want to make for problems like these. If x ever shows up outside of your absolute value expression, this is definitely one of those situations where you are going to need to test to see if you have any extraneous solutions, okay? Wasn't necessarily from before because we did not have x showing up outside of the absolute value expression, but here we absolutely do. So I'm just going to go ahead and check really quick using my calculator to see if I have any extraneous solutions. I'm just going to store my number into x and then type in both sides and see if I get the same thing. What you will find here is that you're going to have to throw out some of the solutions that you ended up with here. Namely, you're going to find that you're going to have to throw out the x is equal to 1, and you're also going to have to throw out x is equal to negative the square root of 3, okay? So in which case you would end up with the following results here. You would get x is equal to negative 3 as one of your solutions, and x is equal to the positive square root of 3 as your other solution. We're going to have to throw those other ones out because they did not create the same number on both sides of our equal sign. So that's going to be very important to have to keep track of, okay? So one more example here in this video, and then we'll call it quits. Number 5. So again, the exact same thing. We're going to interpret the absolute value as the distance away from 0, okay? And so if we do that here, we have our number line. And here is 0. And again, how we interpret this is in the following way. We're taking the absolute value of this number right here, x plus 1, and we're saying that it is this many steps away from 0. So we are a number of steps away from 0 equal to x squared minus 5 steps away from 0. So if I were to go to that direction to the right, I would end up at positive x squared minus 5. If I were to go that in the left direction, I would end up at the negative version of that number, which is negative x squared minus 5. Okay? And so I know that this yellow number in between the bars is either going to be this candidate right here or it's going to be this candidate right here, meaning that I'm going to set my equation up in the following way. I'm either going to have the negative version of this number is equal to the number in between the bars, or I'm going to have the positive version of that number is equal to that number in between the bars. And that just sets up for me two quadratic equations that I'm just going to go ahead and continue to solve using the exact same methods that we discussed before, right? So distribute that negative in on the left-hand side here, and then bring all your terms over to the other side here, right? So you might go ahead and subtract x from both sides, and we'll kill two birds with one stone here. We'll subtract that 1 as well. We end up here with negative x squared minus x plus 4 is equal to 0, and we could just go ahead and factor out that negative 1 now and continue to factor this trinomial in the following way. We would end up here with x, and then looking for two numbers that multiply to make negative 4 but add to make positive 1. Is that going to work out for us here? Let us see. I don't believe that will factor, unfortunately. So we are going to have to use some quadratic formula to go ahead and perform the rest of this. And so keep quadratic formula pretty handy because it comes up, right? So a is equal to 1, b is equal to 1, and c is equal to negative 4 here. So I know that x is going to be equal to the opposite sign of b, which is negative 1, plus or minus the square root of your b squared minus 4 times a times c. Just setting this up really quick. And then dividing all that by 2 times a, okay? Now that discriminant part, the part under the square root, that could be a part that you do mentally or by hand, or in the calculator even. I believe what you're going to find there is that that number is going to be a positive 17, okay? And so what we would end up with here are two solutions for x. We would end up with negative 1/2 plus or minus the square root of 17 over 2. Okay, so those would be the two real number solutions that we end up with in that first case. If we go ahead and do the second case, subtract the x to the other side, and also subtract that 1 as well, with the following. We end up with positive x squared minus x minus 6 is equal to 0. Okay, now does that factor for us? I think we can get that factor. So x, and the numbers, maybe some combination of 2 and 3 would work for us pretty nicely here. What if we did a negative 3 and a positive 2? I think that would work great. Okay, in which case we could do zero product property and get our two zeros here pretty immediately. That's going to be x is equal to negative 2 and x is equal to positive 3. And again, because x showed up outside of the absolute value bars, this is going to have to be one that you check for yourself, okay? Because you might have to throw out some of these solutions. It may not necessarily be the case that you have to throw out all of them, but definitely is something that we are going to have to check to make sure if you have any extraneous solutions or not, okay? And so I definitely think we are going to here. I just used my calculator to check my solutions, and one of the things that we will notice here is that we are going to eventually have to throw out your x is equal to negative 2. That is an extraneous solution. And we're also going to have to throw out your negative 1/2 plus the square root of 17 over 2. So we end up with the following two solutions. These are the only ones that are going to work. Okay, so we're going to end up with negative 1/2 minus the square root of 17 over 2. That's one of our solutions. So I'll box that. And we also end up here with your x is equal to 3 as your other solution. So we had to throw out the plus there, and we also had to throw out your x is equal to negative 2 there in that equation, okay? So again, when you have an absolute value equation, if you have x showing up outside of the absolute value bars, you are going to have to check to see if you have extraneous solutions. If you don't have x showing up outside the absolute value bars, then you could just go ahead and split it up as normal, find your conclusion. In the case of number 3, if you ever see that the absolute value bars equals a negative number, we're saying that we are a number of negative steps away from 0, which doesn't make any sense, in which case you're just going to say no solution. But that's all I have for this part 1 of this video for day 2. Make sure that you watch the part 2 for day 2. That's going to talk about your radical equations. But that's all I have for this one. Thank you very much, and I will speak to you in the next one.